Why are we here? And I don't mean that in some big philosophical sense. I mean physically. Why does our universe have the very specific properties that allow for stars, for planets, and, well, for us to exist at all? We are about to dive into one of the biggest, most mind-bending questions in all of science. Because, when you actually look at the numbers, our existence seems ridiculously improbable. The fundamental constants of nature, the basic rules of the game, they seem to be balanced on a knife's edge. If you nudge any one of them, just a tiny bit, the whole universe would be a sterile, empty void. Okay, let's just take one number, the cosmological constant. This is the energy in empty space that's driving the universe to expand. Its value is so absurdly precise that the odds of it landing in the life-permitting range by pure chance are about 1 in 10 to the power of 120. That is a 1 followed by 120 zeros. It's such a staggering number that physicists call it the mother of all physics problems.
And it's not just that one dial. Imagine a massive cosmic control board. You've got dials for the strong nuclear force, for gravity, for the initial lumpiness of the universe, and they're all tuned to these incredibly specific, life-permitting values. Tweak one, and poof, you either get a universe with only hydrogen, or one that's just a bunch of black holes, or one that collapses back on itself before it even gets started.
So, what on earth explains this? In this explainer, we're going to walk through the two biggest ideas out there. First, we'll look at the designer hypothesis and its critiques. Then, we'll dive into the main scientific alternative, the multiverse, and its own set of weird problems. And finally, we'll see where that leaves us.
All right, so let's start with this fundamental observation. The laws of physics don't just allow for life, they seem almost perfectly set up for it. This is what we call the fine-tuning problem, and it's a mystery that really demands an explanation.
The most straightforward, and for many, the most intuitive answer is, well, maybe it wasn't an accident. The designer hypothesis says that those cosmic dials were set on purpose, that the universe was intentionally crafted to allow for beings like us to come into existence.
The logic here is pretty compelling. It's captured by what the philosopher Peter van Inwagen called the merchant's thumb principle. Basically, it says that when something happens that is just wildly improbable, but there's a really good explanation staring you in the face, it's not rational to just shrug and say, wow, what a coincidence.
And this is the perfect analogy. Imagine your life is on the line, and you have to pull the one short straw out of a million to survive. And you do it. Your first thought isn't going to be, man, I'm lucky. No way. It's going to be, wait a second, this was rigged. The fine-tuning argument applies that exact same logic to the entire cosmos. Our universe is that one special straw.
But as powerful as that intuition is, it runs into some really serious philosophical and logical problems. The critiques of the design hypothesis are not trivial. They cut right to the core of the argument.
We're going to touch on 3 of the biggest ones. First, there's that classic question, who designed the designer? Then there's a more technical problem with whether we can even talk about improbability here. And finally, there's the fact that we're really just guessing what a cosmic designer would even want.
So that first one is probably the most famous, often associated with Richard Dawkins. It's the regress argument. If you say the universe is so complex it must have had a designer, then that designer must be even more complex, right? So then who designed the designer? You haven't actually solved the problem of complexity. You've just kicked it up a level into an endless chain.
The weaknesses in the design argument really force our hand. They make us ask, okay, if the cosmic dials weren't set on purpose, is there any other way to explain our unbelievable luck? And this brings us to the leading scientific alternative, the multiverse. Now, what's crucial here is that the multiverse wasn't just invented to solve this fine-tuning problem. It's an idea that naturally pops out of the mathematics of some of our most advanced physical theories.
The modern idea of the multiverse really stands on 2 pillars. First, you've got cosmic inflation, our best theory for the universe's explosive birth. It suggests our Big Bang was just one of countless others, creating this cosmic foam of bubble universes. And second, you've got string theory, which predicts a massive landscape of possible physical laws, something like 10 to the 500 different sets of blueprints for how a universe could work.
So put those 2 ideas together, and what do you get? You get a cosmic lottery. If you have a universe generator churning out endless bubbles and a giant library of physical laws for them to use, it's no longer surprising that one would hit the life-permitting jackpot. Our fine-tuned universe isn't a miracle anymore. It's a statistical inevitability. We're just living on one of the winning tickets.
But, and this is a huge but,
The multiverse is far from a settled case. It comes with its own heavy-duty baggage of scientific and philosophical problems, and some of them are frankly just weird.
The objections are serious and come from top thinkers. Some philosophers say it's a basic logical error. You can't see one lottery winner and conclude there must have been millions of tickets. Physicists like George Ellis argue it isn't even science because we can never test or observe these other universes. And then Paul Davies points out a really strange paradox. If the multiverse is real, it might mean we're actually living in a simulation, which throws out the very physics we use to predict it.
But maybe the most powerful, and by far the strangest, objection comes from inside the theory itself. The multiverse makes a prediction that is so bizarre, it threatens to unravel our entire understanding of reality.
Yeah, you heard that right. Many multiverse models predict that it's statistically way more likely for a single, conscious brain with a full set of false memories to randomly pop into existence out of chaos than it is for our entire, complex, ordered universe to form. If the theory is right, we should probably be one of these Boltzmann brains. The fact that we're pretty sure we're not, well, that suggests the theory has a very big problem.
So here we are. We're left with this epic choice between two grand, and let's be honest, deeply unsatisfying explanations. One based on purpose, and the other based on probability.
So how do we choose? A classic tool is Occam's razor. The simplest explanation wins. But what does simple mean here? The designer idea is simple in one way. You only add one new thing, a designer. But it's complex, because that's a whole new kind of thing, a supernatural mind. The multiverse, on the other hand, is complex in the number of things it proposes, zillions of universes, but it's actually simple in that it doesn't invent new kinds of causes. It's just more of what we already understand, physical laws and variation.
You know, in the end, the multiverse explanation follows this pattern we've seen in science over and over. We used to think Earth was the center of everything until Copernicus. We thought humans were uniquely created until Darwin. The multiverse does the same thing for our entire cosmos. It suggests that its specialness is just an illusion, a matter of our own limited perspective.
And that leaves us right here with the ultimate question. Is this finely tuned reality we find ourselves in a deliberate, singular masterpiece? Or are we just the incredibly lucky winners of an unimaginably vast cosmic lottery? For now, science can't give us the final answer. We're just left to wonder at the profound mystery of our own existence.